Okay, so in today's class, we are going to learn the next concept in our pointers. In the up to our last class, we learned about what is a pointer and what type of arithmetic operations can be performed using pointers, and how a variable value and an address can be accessed by using pointer. That means we learned the pointer declaration, initialization, and we learned about how pointers can be combined with functions, and also we learned about pointers, how they can be combined with one-dimensional arrays. Okay, in today's class, let us learn about how a pointer can be combined to a two-dimensional array. So up to our last class, we have concluded with pointers with one-dimensional array, how a one-dimensional array, if it is declared, how the individual values can be accessed by using pointers. All these things we learned in our last class. Okay, so pointer to an array if we are talking about, here I am talking only about two-dimensional arrays. Okay, you all know how to declare a two-dimensional array. The normal way of declaring a two-dimensional array is we need to specify the data type, you need to give the array name, and then you need to specify the row size and column size. Now, if you want to assign a pointer to a two-dimensional array, you need to do that one by writing a pointer variable, and you need to specify the size, and that size should be a column size equal to the array address whichever you want to store. I'm repeating once again. If you are declaring a normal array, two-dimensional array like this approach you all know. But if you want to use a pointer to store the address of a two-dimensional array, then you need to put star, you need to give the variable name, so it will be considered as a pointer variable. But if you want to store this pointer variable a two-dimensional array, then you need to specify the size, and that size should be equal to this array name size, column size. So if you give the column of 5, then this should be 5. No need to mention the row size, you need to mention the column size. So this is how a pointer can be declared. An example you can see here, if you write, let us consider, you can declare a two-dimensional array like this, where num is a variable name, array name, and it is capable of storing 10 rows, and each row will be having 20 values. This can be declared as a pointer to an array. If you want to have a pointer to an array, this can also be written like this, simply by converting this normal array to a pointer variable where I am mentioning the column size. Now what do you mean by mentioning like this? Now num is a pointer variable which holds the address or addresses of one-dimensional arrays. What do you mean by that one? I'll tell you. You can see here, it is nothing but we are trying to create one-dimensional arrays which will be having, this is one-dimensional array, here you will be having 20 values. Okay, and also we will be creating one more one-dimensional array which is also having 20 values, and also we will be having one more one-dimensional array which is holding 20 values. So num, whatever we are declaring here, num will be holding the addresses of the initial addresses of these rows. So it is not, it is holding all these addresses. How many values you are storing, that many number of rows will be created, and each row will be holding 20 values. That is what it will be told. Got it? Now if you want to, in detail I'll explain in the future slides. If you want to, let us consider, if you want to get a value of a particular location, let us consider if you want to get this location value, and if it is of ith row and jth column, if you want to access that one, the notation we need to use is this notation. What is that notation? You need to get a particular row address, and that in that particular row address you need to get a particular column value. Okay, so this is how you can access the value. If you remove this star, you will be getting the address. Right? To understand this concept, let us take one more example so that it will be clear to you all. We are talking about two-dimensional array. So let us consider you have declared an array like this. Observe carefully all of you. We are trying to create 3 rows. So this is row 1, row 2 and row 3, and each row is capable of storing 4 values. We have declared like this, so we have initialized the values 4 values. Now if you write like this, this picture will come into our mind where row 1 will be holding 1, 2, 3, 4 values, and row 2 will be holding 5, 6, 7, 8 values, and row 3 will be holding 9, 10, 11, 12 values, and these are called as columns and these are called as rows. right? So whenever you declare like this is the thing that comes into our mind. But internally what happens? How the memory will be allocated? The memory will be allocated like this. Remember, continuous memory location. That means first row will be stored. That means row 1 will be stored, and then second row values will be stored. Observe carefully how the memory address is given. Let us consider the starting address is 5000. Now it depends upon the like if it takes 4 bytes, then 5004 will be taken by the second value, 5008 will be taken by the third value, 5012 will be taken by the fourth value, and then it comes to the next row, next 4 more bytes will be taken and it will be stored here, next 4 more bytes will be taken and it will be stored here. So for row 2 will be filled, and then it will comes row 3 that will be stored. So continuous memory locations will be allocated row by row. You need to understand. So in two-dimensional array, the memory will be allocated like one first array. This is referred as one-dimensional array, isn't it or not? Can this be considered as one-dimensional array? So one-dimensional array, one row will be considered as one-dimensional array. So after placing one-dimensional array, then another one-dimensional array will be placed. That is nothing but another row. This is how internally in memory the data will be stored. I hope you all are clear with this one. So if this is clear, then we can proceed further. So now we all understood like the data will be stored in the memory like this. First row and then second row and then third row. This will be the starting address 5000, and then 4 bytes will be allocated individually for each depending upon the data type. Now what happens? By using simply ARR name, we can point to the first row. If you want to refer to the second row, we need to simply write ARR plus 1, because you all know array name itself will be considering the address of the first element. You remember one-dimensional array what we discussed? The same thing, but here remember, if you are using the normal array name, what is our array name? ARR. If you directly write ARR, it is nothing but we are pointing to the first row totally. And if to refer to the second row, you can write ARR plus 1. This refers to the second row. Okay. Then the ARR plus 2 refers to the third row. Now generally how can we write? We can write ARR will be pointing to the 0th one-dimensional array, and what is the base address? 5000. So ARR will be holding the 5000. What do you mean by 5000? Remember, ARR will be pointing to this complete one-dimensional array and its base address is 5000. ARR plus 1 will be pointing from, this is completely your ARR plus 1. So ARR plus 1 is nothing but this one. It will be holding 5016. That is what told here. So it points to the first one-dimensional array. This is 0th one-dimensional array. This is first one-dimensional array. This is second one-dimensional array. Okay. So this will be holding a value of 5016. And ARR plus 2 will be holding the value of 5032. That is what told here. You can see here ARR of 2 will be plus 2 will be holding of 5032. So simply adding a one value to the base address of 5000, you can get a chance to visit to the next row. Got it all of you? So this is how, now generally how can we write now? So in general, we can say ARR plus 1. ARR plus 1 will be representing to the first row. So we can say ARR of plus I points to the ith one-dimensional array. Is that clear all of you? If ARR plus 1 is pointing to the first one-dimensional array, then ARR of I points to the ith one-dimensional array. This you need to be clear all of you. Okay, is this allocation clear to you all? How the representation is done, everything? Is this clear to you all? Remember, ARR will be pointing to the complete row. Don't get confused. Now, let us move further. Now what happens? You all are clear with this general notation. ARR plus I will be pointing to the ith row. You all are clear with this general notation. Now, simply by putting star in front of this one. Observe here what I have done. Earlier, we have taken ARR plus 1 only, but in front of that one I have put the star symbol. If we are putting the star symbol, that means we are pointing to the 0th element of the first row. What do you mean by that one? I'll tell you. That means if you see this diagram, ARR, what I have written? ARR plus 1, and to the whole thing I have kept star. What do you mean by that one? You are referring to the 0th element. Is this the 0th element of our first row? Got it? If you write star ARR of plus 2, what do you mean by that one? You need to refer to the second row. Obviously we need to refer to the second row. If you put star in front of that one, we are referring to the 0th element of our second row. Got it? Observe the difference between ARR plus 1. There is a lot of difference between ARR plus 1 and star of ARR plus 1. Both will be holding the base address only, but what is the difference is ARR plus 1 will be referring to the complete row. To this complete row it will refer, but ARR star of ARR plus 1 will be referring to the zeroth element of your first row. Got it? That is what it is told here. Observe here. Star of ARR plus 1 will be referring to the 0th element of your first row. So in general, what can we say? Star of ARR plus I, you can say like it will be holding to the 0th element of the ith row of the one-dimensional array. So observe the difference, all of you. Again, I am repeating, there is a difference between ARR plus 1 and star of ARR plus I. What do you mean by that one? ARR plus I will be pointing to the complete row, which is holding 4 values in our case. But star of ARRI plus 1 plus I is nothing but it is pointing to the 0th element of our first one-dimensional array. Got it? 0th element is nothing but the first location. Now let us see the same thing I have taken. So since you all are clear with that, like a star of ARRI plus 1 will be pointing to the 0th element. 0th element. So let us consider star of ARR plus 1. If you write like this, what do you mean by this one? It is pointing to this location, isn't it or not? This is 0, this is 1. So we are now in this row. In this row, a star means it is pointing to this location. That value is 5016. Now if you want to get to the next location values, what you need to do? What you need to do? You need to add another integer to this value to get the next location values of the particular row. Now we are in our particular row. In this particular row, we know how to access the first value. But if you want to get the next location values in the particular row, then what you need to do? You need to add an integer to this ARR plus 1. So what we need to do then? Then if you write, if this is nothing but adding plus 0. It is nothing but you are referring to the first location. In place of 0, if you write 1, that means you are referring to the next element. In place of 1, if you write 2, then it is nothing but you are referring to this element. Are you understanding, all of you? So the same thing I have written here. Star of ARRI plus 1 will be representing the address of first element of the first. So what do you mean by that one? So this one, whatever I have written here, it is referring to this location. Got it? So how can we write here? Again, I am repeating. I will erase everything and I will show you once again. If you are writing, okay, let me write one more time. If you are writing ARR plus 1, follow carefully all of you. We are referring to this row and it will be holding the base address of 5016 only, but the difference is it is pointing to the 4 values in our example. If I write star of ARR plus 1, what is the meaning of this one? It is pointing to the first value of this particular row. What is the first, not first value, address? What is that one? 5016. So this is also holding 5016 only. But don't get confused between these two. It is pointing to 4 values. It is pointing to 1 value only. Okay. Now we are successful in getting the first address. But if you want to get this address or this address or this address, we need to add a new integer to this one. So this can be converted as adding the index. 0 index, if you are adding this, we are referring. Suppose if you write star of ARR plus 1 And if you add an index of 1, what do you mean by that one? We are referring to this location. So that is nothing but we are referring to 5020. Okay. Remember, this gives the address only, not the value. What I am writing here, it is address only, not the value. Okay. And then if you write star of ARR plus 1, if I write the next index of 2, it will refer to which one? This one. So you will be getting an address of 5024. We are not referring the value, we are referring the address only. Got it? So can we generalize this one? How can we generalize this one? ARR plus 1. Can we generalize this one? ARR plus I plus 1. What do you mean by that one? It has been generalized like this. For a particular ith row, it will refer to the first index element. Isn't it or not? For a particular ith row, it will refer to the first index element. As we have written 1 here, it is referring to the first row, not the 0th row. It is referring to the first row. If you write I, it is nothing but it will refer to the particular ith row, and in that particular ith row, it will refer to the ith index element. Similarly, if you see this one, what do you mean by this one? For a particular ith row, it will refer to the second index element. Understood all of you? Referring is nothing but it is pointing to that address. Referring is nothing but we are referring to the address, not the value. But if you want to get the value, what we need to do, I'll tell you. Before this, all of you note down this one. Okay, now you all are clear what is the representation, what do you mean by ARR plus 1 and what is the difference, like putting star in front of this value. This will point to the base address only, but it is pointing to the 4 values, whereas this will be pointing to that particular location only. And you all are also clear with this individual values, how can we get by using this formula. Okay, so let us see how to get the value. Now we have written a generalized value here. Star of ARR plus I plus 1 if you write. What is the meaning of this one? Ith row first index element. So you can generalize this one by simply putting this one with J. What do you mean by that one? Ith row particular jth index element we are referring. Got it? So A of ij if you are writing, then the address of A of ij can be referred by using star of ARR plus I plus j. Address, I am talking about the address. Got it? So the address of, normally the address will be written as ampersand. So ampersand of A of ij, if the array name is A, then the ampersand of A of ij, if you want to get the address of this particular ith row and jth value, then that can be done by putting star ARR plus I plus j also. Okay. Now is this clear to you all? Now, so with this, you see the notation all of you. What do you mean by ARR? ARR is nothing but directly your array name which is pointing to the 0th one-dimensional index. Star of, to understand this one, see this diagram all of you. We have taken the same example. If you write ARR, ARR will be, if you use simple ARR, it will be pointing to the next row. This we have already learned. Now, if you put star ARR, it is nothing but it is pointing to the 0th element. This element it is pointing. Okay. If you write ARR plus 1, we already know ARR plus I is nothing but pointing to the ith one-dimensional array. This notation we already know what is represented here. Now, if you put star of ARR plus I, it is nothing but it is pointing. Let us consider star of, again I am repeating this one, ARR plus 1 if you write. What do you mean by this one? It is pointing to the 0th element of our first row. Okay. And if you write, simply this has been represented with j once again. What do you mean by that one? In the first row, jth element will be representing. So if you write in place of j, if you write 2, let us consider, then what happens? If this is 0, this is 1, this is 2, it is pointing to this location. So this will be pointing to this location. That is what generalized like this. Now this location is nothing but this address. But if you want to get this 7 value, then again you need to put in front of this one more star. Then you will be getting the value of that location. This gives the address and this gives the value. All of you listen carefully. So if you see here, star of ARR plus 2 will be pointing to this location. Star of ARR plus 2 plus 3 is nothing but 0, 1, 2, 3. This location it is pointing. But at this address, if you want to get this 12 value, then what you need to do? You need to put the star in front of that one. I hope you all are clear with these representations in your two-dimensional array. One-dimensional array pointer representation and two-dimensional array pointer representation is a little bit different, because in two-dimensional array we have multiple rows and each row will be considered as your one-dimensional array. Is this representation clear to you all? Is this representation clear? This diagram depicts everything whatever we have discussed. ARR will be holding the first row. Star ARR will be pointing to the first. Pointing is nothing but address. Whenever I am saying pointing is nothing but address. Represents the value is nothing but a particular value. Okay? Is this clear all of you? Now let us see example under this. See, I want to store the matrix element of a two-dimensional array. Listen carefully. I want to store the matrix elements. Now, if you see here, I have declared a pointer array. Remember here, I am not using a normal array concept. I am using a pointer array concept. And if you see here, P is my pointer array, and it is capable of storing, it is a two-dimensional array, and the column size of each row is 3. What do you mean by that one? I don't know how many rows are there, but each row is capable of storing 3 values. Follow carefully all of you. Now to know the number of rows, I am asking the user to enter the number of rows. The number of rows are m. Suppose if m is 2, then it is nothing but I want to create 2 rows. Okay, m value is 2, nothing but I want to create 2 rows and each row is capable of storing 3 values. This is what I am trying to do. If the m value is 4, we want to create 4 rows. Each row is capable of 3. Got it? Now if you are writing like this, it is nothing but P is pointing to the first row. P is pointing to the first row, complete row. If I write P plus 1, what do you mean by that one? P is pointing to the next row. Okay? Is that clear all of you? Now I want to read the values for this matrix. How can we read the values for this matrix? We need to start from I equal to 0 and how many rows we have? 2 rows, and that value is stored in m. So the loop is repeated m times, and for each row, if you are in this row, for each row we need to access 3 values, so that I have written again one more j. This logic is I think you all are familiar with this logic. The way we have perform the matrix operations, there we have asked the user to enter the m by n rows, r by c column row values and column values. Here in our case the j value is 3 and this loop will be repeated 3 times for a particular row. And how we are reading the values, you need to observe this one. Normally how we use it to read the values, do you remember? Ampersand of, let us consider the array is a of let us consider 2, 3. Then how we used to this 2 is now saved in our m value. Okay. Now how we used to write I equal to 0, I less than m, I plus plus, j equal to 0, j less than 3, j plus plus. And how we used to write scanf percentage d ampersand of ij. Now I already told you, if you are using a pointer concept, this address how we will be getting? How we are getting? We need to get this address. Got it? Shall I show you the earlier slide? How we are getting an address? We are getting the address using this location, star of which are pointer variable, you are using that one, plus I plus j. Same thing we have to write here, star of p plus I plus j. Understood all of you? Now this is how, this is the loop that will be used to read the, in our case if m value is 2, you will be reading 6 values. And first 3 values will be stored in first row and the next 3 values will be stored in the next row. you are successful in reading the values. So if you want to display the values, what you need to do, again we need to use for loop, and each row 3 times you need to display the values. So normally how we used to write printer percentage d, we will be writing a of ij only, no ampersand will be used. That means we want to get the value. To get the value, what you need to do, you have this one to get the address. In front of that you need to put the star. Isn't it or not? That is what we have learned in the earlier slide. This thing, if you see this thing, if you want to get the value, whatever address you have, to that you need to put the star. So that is what we have done here. We have put the star, which is nothing but representing the particular value, and this is nothing but pointing to that particular location. Got it? So this is how a two-dimensional array values can be accessed and can be displayed. Now I think you all can write a program to convert like to perform matrix addition using pointers. Can you all do? Can you all do how to perform the matrix addition using the pointers? Suppose if you are asked to do the matrix addition using pointers, how you can do? You can take this one, 2 pointer arrays they are required, one p1, and you can take one more pointer variable p2. Okay, and then what you need to do, 3 you need to take, and you need to perform the addition. Read the values of first matrix and read the values of second matrix. Then how can you do? Simply perform the addition. How you can perform the addition? Shall I write here? First value, 2 for loops you need to write. I am not writing that one. And star, first value, how you will be getting? P1 plus I plus j. This is nothing but, this is talking about the first matrix element, plus, okay, star of, again star, let me erase this one, star of p2 plus I plus j. This you can store in C of ij. Directly you take one more array and store it in C of ij. This is nothing but, what do you mean by this one? This is nothing but A of ij. Isn't it or not? The way we have written for our normal array addition. And this is nothing but B of ij. So whenever you are asked to perform any matrix operations using pointers, I hope you can simply do by just using this formula. Is this clear, all of you, how to perform? Is this clear? So this is how addition operation can be performed between the two matrices. If you want to perform subtraction, simply replace this one with minus. And if you want to perform the multiplication, I think you all know the logic how to perform the multiplication. Okay. Now this has been represented like this. See what I have done? P will be pointing to the, as this is an array, it will be pointing to the starting address, that is 1048, let us consider, and this 1048 will be again pointing to the 3 more values. That is what we have learned. Okay, and this is your first row, this is row 1, and this is your row 2. If you want to, if you are storing the values like this, then P will be pointing to 1048 and P plus 1 will be pointing to, sorry, P plus 1 will be holding the value of this one. Got it? This is how the memory representation will be done internally. Okay, with this, like two-dimensional arrays, how a pointer can be connected with our two-dimensional arrays is, can be done like this. Is this concept clear to you all?